Okay, sorry about that. There's a little error with my PDF. May not notice. 17 is where we start working with polynomials. Okay, 17 is where we start working with polynomials. Again, same direction, add, subtract, or simplify, and give your answer, and it should say simplest form, but yes, in a simple form, okay? Show your process. Do not do these in your head, okay? Work them out slowly. Let us see the work. You'll get some partial credit. 17 is a subtraction problem. Don't just immediately look at this and think, ooh, multiply. This is a subtraction problem. And first thing I'm going to do, and you don't have to do it this way, but the first thing I'm going to do is I'm going to make it into an addition problem by distributing that negative sign. That means I've got a negative 8a squared minus 6a to the fourth power. Now I can just look back and forth from here, our original, and this new part that we distributed to, and we can just combine like terms. I see I have a pair of like terms there and there. Those are going to combine. They're like terms because they have the same exact variable, a squared and a squared. So those are going to combine to be a negative 2a squared. I see I have another set of like terms here and here that are going to combine to be a negative 8a to the fourth power. And then my only thing that didn't pair up just has to come down by itself, 5a cubed. This is a correct answer, but it's not the best answer. The best answer would be to write these in descending order according to the variable powers. And that just means it's a fancy way of saying you write a to the fourth power first because it's the highest number, up top, not out front, up top, plus 5a cubed minus 2a squared. That would really be your perfect answer, but both of them are right, okay? Number 18, again, it's a subtraction problem, so we're going to take that subtraction sign and we're going to go ahead and just make it an addition problem by distributing it. This is negative 5k to the fourth, positive 2k squared, and negative 2k cubed. It just changed all three of these signs from positive to negative, negative to positive, positive to negative. Now we can just look back and forth between our new writing and our original trinomial and find some like terms. I see that I've got a k to the fourth power and a k to the fourth power. When I combine those, I'm going to get a negative 4k to the fourth power. I've got a k squared and another k squared. When I combine those, I'm going to get a positive 4k squared. I'm just working with the numbers out front. And then I see that I have a piece all by itself and another piece all by itself. They just have to get tagged on. Negative 2k cubed and positive 7. Again, a right answer, but not a perfect answer. K to the fourth is our highest power, so it goes out front. Negative 2k cubed really should be written next with 4k squared following, and then our constant at the end. This is normally the way, if I would write my fourth power, this is normally the way this will be written, and that is always the way it's probably going to be written if it's on a multiple choice test. For number 19, this is a multiplication problem, and namely, it's a distribution problem. So that negative 2x squared has to go to both of those terms. But when it multiplies here, x squared times x just bumps up the power by 1, so we get negative 2x cubed. Here, there's no x's to multiply by, but there's a number, so we multiply, and we get positive 8, because negative 2 and negative 4 are positive 8, x squared. Very quick, easy problem, just a distribution. 20 is a bit harder. It's still a number and a variable, but we've got to distribute it 3 times because this is a trinomial. Trinomial meaning 3 distinct pieces separated by addition or subtraction. 4r times r squared, well, it's just a 4r, but this is cubed. R times r squared is r cubed. It bumps the power up 1. 4r times 2r, well, there's some numbers we have to multiply to get 8. R times r is r squared. Our final multiplication results in 20r. Okay? For 21, this is another multiplication problem, but this is done by distribution, otherwise known as the window method. I'm going to show this one with the window method. If you didn't do it with the window method, you should get the same answer. I'll show some of the other ones by distribution later. This one I'm going to show by the window method just for the students that are used to it and like it better. First, you build your window. Then you put your polynomials on it. 5n, positive 1, 4n, positive 2. The sign goes with the number. Then we fill in all of our window panes. 4n times 5n is 20n squared. 5 times 2 is 10n. Doesn't matter what order you go in. 4 times 1, that's this window pane right here, is 4n. And 2 times 1 is 2. Notice, a lot of times it'll work out that our diagonals have our like terms. Not always, but most of the time. When it does, you can go ahead and combine them when you write your answer. 20n squared plus 14n, that came from 10n and 4n. Make sure they're like terms though. Some of these other ones, it won't work that way, okay? Plus 2. Again, this 14n came because we had 10n plus 4n would have been what this is. Okay, so it became 14n.